Hello, geometry. So some people are having trouble deciding which ones are notes and like which papers to return and stuff. So we're gonna start trying to put like notes on top so you know that this one is the notes. So this is our notes for angle pairs. So we want to know about the relationship of different angles. So this first part, all vocabulary. Okay. So our first angle pair that we have here is adjacent angles. Does anybody know what adjacent means? If you know what adjacent means, then it really makes sense. But adjacent angles are two coplanar angles with a common side, a common vertex, and no common, and this should say interior points. Well, that's a lot of words. So basically, adjacent angles, adjacent means next to. So adjacent angles are just angles that are next to each other. So if I draw two rays that intersect, and then I put another ray in between them, these would make adjacent angles. So if I notice these two angles, they share a side, this is their common side, and they share a vertex. When it says no common interior points, that means that there's no overlapping. So these two angles share the vertex and they share a side, so those are adjacent angles. They're right next to each other. So angle 1 and angle 2, they are adjacent. So they're next to each other. Our next one is vertical angles. So vertical angles are two angles whose sides are opposite rays. So basically, if I have a point here, these are opposite rays. They share the same endpoint, they go in the opposite direction. These are opposite rays. They share endpoint, they go in opposite direction. So basically when it's looking like that X. So when you have two lines crossing and they form that X, that's going to give us our vertical angles. So if I name the four angles that are created here, I have 1, 2, 3, and 4. So my vertical angles will be the angles that are right across from each other. The ones that sides are opposite rays. So angle 1 and angle 3, those are vertical angles. Their sides are opposite rays of each other. Angle 2 and angle 4, those are vertical angles. So again, for me, anytime I see two lines meeting and they form that X, the ones right across from each other, those are my vertical angles. Now, another thing about vertical angles is vertical angles are congruent. That means that they're the same. So not only do I know that these are vertical angles, I can also say that the measure of angle 1 equals the measure of angle 3, or the measure of angle 2 equals the measure of angle 4. So those are vertical angles. Complementary angles are two angles whose measures have a sum of 90 degrees. Each angle is called the complement. So when I have two angles that together add up to be 90 degrees, those are called complementary angles. So a common way we see it is if we have a right angle. Again, I know it's a marked right angle because it's marked as a right angle. If they don't mark it as a right angle, I can't assume it is. So you'll have a right angle and then you might have like a ray that divides it somehow. And so this is 1 and this is 2. So angle 1 and angle 2 are complementary because together they add up to be 90 degrees. So the measure of angle 1 plus the measure of angle 2 equals 90. Now the thing though, with complementary angles, they don't have to be adjacent. You remember adjacent means they next to each other, they're sharing that vertex to that side. They don't always have to be adjacent. I could give you two angles. Let's say that they're not touching and stuff, but I can tell you that this one right here is 30 degrees and this is 60 degrees. These two angles are complementary because they add up to be 90 degrees. So when you have two angles that add up to be 90 degrees, they are complementary. Supplementary is similar, but your two angles whose measures have a sum of 180, they add up to be 180. And these are called supplement. So each angle is called its supplement. So an easy way is that it's commonly seen. I have a straight line, a straight angle, and then you have some part from it. And these two angles, angle 1 and angle 2, together they equal 180 degrees. So a straight line we know adds up to be 180, is half of the circle. So when you have a straight line, the two angles that are making that line, those can be supplementary. So angle 1 and angle 2 are supplementary. The measure of angle 1 plus the measure of angle 2 equals 180 degrees. Now and again, this does not mean they have to be adjacent. The two angles do not have to be attached. I can draw two separate angles. I can tell you this is 150 degrees and this is 30 degrees. Even though they're not touching, even though they don't share a common vertex or anything, they are still supplementary to each other because when I add them together, they equal 180. Okay? So when two angles add together to equal 180, they are supplementary. So now down here, this is just about identifying it. So what we want to do here is we want to identify any adjacent angles. In this right here, if you just mark your paper, that's just marking saying that those are congruent. But now let's go back here. So adjacent angles. Adjacent angles, again, are any angles they have to share the same vertex. If I notice all these angles have the same vertex, so this making it a lot easier for me. But they got to share the same vertex, and they also have to share a side. So they got to be next to each other. Adjacent means next to. So I can see angle 1 and angle 2, those are adjacent. They're right next to each other. They're sharing a side. 2 and 3, those are adjacent. 3 and 4, those are adjacent. We can keep going. Angle 4 and 5, and angle 5 and 1. All right here. Those are all adjacent. They're right next to each other. And they're sharing that vertex. Vertical angles. So again, with vertical angles, I need to have opposite rays. So I need to look for lines. So I have a line here, and I also have a line here. So these two lines intersecting, making that X. Angle 3 and angle 5, these are vertical angles. Complementary. So complementary are two angles that add up to be 90 degrees. Now I don't have anything here marked as a 90-degree angle, so I can't just say something is. And I don't know any measures, so I don't know anything's going to add up to be 90. So we can't say that there's any complementary in this one. Supplementary. Again, I don't have 90, so I can't use that. But again, supplementary, we know that a straight line, a straight angle is 180 degrees. So if I have two angles make a line, those are going to be supplementary. So angle 4 and angle 5 are supplementary. When I add those two together, it's going to equal 180. Same thing with 3 and 4. Angle 3 and angle 4, they're creating this straight line. So angle 3 and angle 4 are supplementary. Again, it's two angles that come together and add up to be 180. Now on this side, and this is the fun part too sometimes, they're asking us, okay, well, what's the measure of all these angles? I know that this might be harder to see on your paper, so I'm going to write this for you. This one's 62 degrees if you can't see it. So angle AFE is 62 degrees. This is 28 degrees. Angle BFC is 28 degrees. And this is 118 degrees. So angle EFD is 118. We haven't really talked about angles yet, so we will get to angles more too, like this is our intro to it. But with angles, when I name them, I can name it with just the vertex if it's the only angle at the vertex. But if there's more than one angle at the vertex, then that's when you got to use all 3 points that make up that angle. So when they say angle AFE, they're saying you start at A, F is the vertex, E. So AFE. So that's 62 degrees. So they want to know this angle right here. And then they said angle EFD. So here's E, F has to be my vertex, and here's D. So go in the order that it's written in. So AFE and EFD are these two angles right here. Well, I know one, these are adjacent because they're next to each other, so I can write adjacent. But let's see, do they add up to be anything? 118 plus 62. 118 plus 62, ooh, that adds up to be 180. So not only are they adjacent, but they're supplementary as well. So that's what those angles are. Well, now they're asking me about AFE, which is the same angle right here, which is 62 degrees. And then BFC, that's this angle right here. Well, they're definitely not adjacent, so I can't say adjacent. They're not vertical angles because they're not formed by two opposite rays. If I can see, it's not a big X there. Well, let me see if I can see anything about what they add up to be. So this one is 62 degrees, and this one is 28 degrees. When I add 62 plus 28, oh, I get 90. So these are complementary. So even though they were not next to each other to make 90 degrees, when I added them together, they equaled 90 degrees, so they're complementary. Go to the next one. So they're talking about BFC, that's this angle right here. And then CFD, that's that angle right there. Well, I don't know much about it yet because I don't really know what CFD is. Oh, wait, maybe I do. But right now we don't. So all we can say right now is they're adjacent. They look like they could be 90, but we can't assume that. And we go to the next one. It says AFE and then CFD. But I notice that's the same angle right there. Well, AFE and CFD, if I notice this right here, that X they're making, they're vertical angles. And I know vertical angles are congruent. So if this is 62, this is 62 as well. So if I go back to the problem before, when I add these two together, not only are these two angles adjacent, but they're also complementary as well. Because they're adding up to be 90 degrees. So when we get to this backside, it's asking about, okay, what's okay to assume and what can we not assume? So here, when they mark these congruent, we know that they're congruent because they told us that. We're not assuming it, it's something they tell us. So we know that WT is congruent to WV. They gave us that information. What I can't assume though is, I can't assume that PW is congruent to WQ. If they don't tell me it's congruent, I can't assume it's congruent. So you can't assume congruence. That's something you can't assume. unless they tell you it's congruent, unless there's some rule like vertical angles are congruent, unless there's something that lets us know, we can't just assume they are. Another thing we can't assume is, we can't assume that this is a 90-degree angle. Just because it looks like it's 90 degrees, if they didn't mark it, they didn't put that little square there, we can't assume that it's 90 degrees. This could be 81 degrees right here. This could be 89, 91, something like that. It doesn't have to be 90. So you can't assume that an angle is 90 degrees. They have to tell you that. So we can't assume congruency. We can't assume that it's a right angle if they don't tell us. But what we can assume, though, is if they look like they're adjacent, we can assume they're adjacent. So if they look like they're sharing a vertex and they look like they're sharing sides, we can say that they're adjacent. We can also assume that, okay, if it looks like these are two things crossing, we got that x, we can assume vertical angles are vertical angles. So when you're looking at something, if it looks like a vertical angle, you can just assume that that's a vertical angle. If it looks adjacent, you can assume that's adjacent. Those are okay to assume. But never assume that something's congruent unless they tell you it's congruent. Never assume that something is a 90-degree angle unless they tell you it's a 90-degree angle. So our last term is a linear pair. So a linear pair is a pair of adjacent angles whose non-common sides are a straight angle. That's just a line. So if we draw a picture, this is my straight angle, which is my line. This is the common side they share. So both angle 1 and angle 2 share this side right here. So this is their non-common side, and it's a straight angle. So linear pairs, if we notice, since they're making that line, they're supplementary. So that's cool. They always going to be supplementary. They're also always adjacent. Linear pairs are adjacent too. So now we're learning one more postulate. So another postulate we can now know is linear pair postulate. So your linear pair postulate says if two angles form a linear pair, then they are supplementary. So if I have two angles, so it's basically the same picture we drew before. Anytime you have two angles and those two angles make a line, they're supplementary. Those two angles are going to add up to be 180 degrees, I'm sorry. So supplementary angles add up to be 180 degrees. Now this last part down here, this is all about knowing their relationships to find the number. So it says, find the measure of all angles. This is hard to see, but they're telling me that's 60 degrees. This marking right here is 90. Well, if I can see I have this line right here. So if this is 90 degrees, this whole thing is 180 because they form a line. And we said when they form a line, it's 180 degrees. So if this is 90, these two together have to be 90. So if this is 60, 90 minus 60, that tells me this has to be 30. Because together they add up to be 180. Well, I can see I have a line here. So if this is 30, this has to be 150. Because 180 minus 30 is 150. These two together have to add up to be 180. Same thing, since you have this line, you can say, okay, 150 plus 30 equals 180. Or you can say, hey, here are vertical angles. So they have to be equal. So knowing the relationships of your different angles, that can help you find different measures. If we go to this problem over here, again, I know this is hard to read. This is 3x plus 6, and this is 6x plus 3. Well, this right here is a marking of a 90-degree angle. So these two angles are complementary. So if I wanted to solve that, I can just say 3x plus 6 plus 6x plus 3 equals 90. To save time, I'm not actually going to solve this out for us, but if we were to solve it, we're going to find out x equals 9. And if x equals 9, then I can go back and plug it into these parts to find out how much each one would be. So this is 6 times 9 plus 3. 6 times 9, 54 plus 3. This is equal to 57 degrees. Well, if I know that these two are complementary, they have to add up to be 90. So I can just subtract 57 from 90, and that gives me this last one, which would have to be 33 degrees. I could also check my work. I can do 3 times 9 plus 6. It's going to give me the same thing. When I come down to this one, again, I know that's hard to see. This right here says x minus 33 degrees, and this says 142 degrees. When you look at this, you should see, hey, I got a linear pair. They're making a straight line. So since they're a linear pair, I just add them together. 142 plus x minus 33 equals 180. That's the equation I could use to solve it. Again, because of time, I'm not going to go through all the steps, but that gives me x equals 71. Well, if I want to know how much this angle is, okay, well then I can do 71 minus 33. So 71 minus 33, that's going to give me 38. So that one over there is equal to 38 degrees. This last one, they're telling me this is 245 degrees. This right here is 32 degrees. And this right here is x minus 39. Well, I know that if I do a complete circle, that's 360 degrees. So they're telling me I only did 245. So I need to do 360 minus 245, and that's going to give me 115. So that tells me that these two angles together have to be 115 degrees. So if I set up my equation, I just add those two parts together. So x minus 39, this angle right here, plus 32 has to equal 115. So these two together equals 115 degrees. And then I solve it. X equals 22. 122, I'm sorry. X equals 122. Well, if x equals 122, then I just plug it in there to figure out how much each of those would be. And that's how we do these. So knowing your relationships, that's going to tell you how to solve them.